We're going to take this up a notch, and we're going to have you guys work out one more ideal gas law problem. This one you can feel free to do in groups, feel free to do with several people in the room and solve, and this is how we're going to either end our day or we're going to work through this, and then any time you have left over in the day, you can work on worksheet number 2, which is all ideal gas law type of problems. So here's our question. How many gallons of CO2 gas, as in a vapor gas, how many gallons of CO2 does one tank of gas produce? Okay, so you drive your car, you use a tank of gas. How many gallons of CO2 are you spitting into our atmosphere when you do that? Okay, so here's your information that'll help you solve the problem. Again, how many gallons of CO2 are made from one tank of gasoline? Well, one tank of gasoline holds 20 gallons of gasoline. Okay, so you're going to start off with 20 gallons of liquid gasoline in your problem. Density of gasoline, we're going to assume to be 0.8 grams per milliliter. Temperature of carbon dioxide at the tailpipe. Okay, so we want to know basically how many gallons of CO2 get spewed at the tailpipe. So we'll say it's about 100 degrees Celsius. It comes out pretty hot, so we'll do 100 degrees Celsius there. Average pressure, okay, it's going to be above atmospheric pressure because it's a pressurized system, so about 110 kilopascals coming out. You have an excess of oxygen, okay? This is a combustion reaction, and yes, you will have to solve for a combustion reaction to make this work. And we're going to assume gasoline is octane, okay? So this is similar to number 74 in the book assignment we had a couple weeks ago, one of your guys' favorite book assignments of all time. So kind of go back to that idea that you're going to have to do some stoichiometry and the ideal gas law to make this happen, okay? Okay, hopefully you guys got a chance to solve it. Hopefully you were able to work your way through that. This was not designed to be an easy question, but I think you guys can handle it, okay? So we're going to work through the process. Now, before I even show you any parts of the answer key, if you take a look at this problem, the key here is we need to figure out how many moles of carbon dioxide do we make. Because once we know the moles, we can then use the ideal gas law, which we just talked about, and we can solve for volume of gas produced. Okay, we can't use 22.4 liters per mole. That's a number that only works at STP, and we're definitely not at STP here. So we had to solve for moles of carbon dioxide and then use the ideal gas law to plug in. So our first step is a little stoichiometry. So we know we have 20 gallons of gasoline. This value here, 1 gallon is 3.785 liters. This is something you would have had to look up. Okay, it wasn't given in the problem, but it's not impossible to know the relationship between gallons and liters. You may have gone a different way, that's fine, but somehow you had to get from gallons of gasoline into liters. 1 liter is 1,000 milliliters, 1 milliliter is 0.8 grams, so that was using your density that was given to you. Octane has a molar mass of 114.26 grams per mole. And if you balance your chemical equation properly, you had 2 moles of octane for every 16 moles of carbon dioxide, or 8-to-1 in there. So you end up with 4,000 moles of carbon dioxide. So we're starting to deal with a really big number here. Okay, so we should expect a gigantic answer in terms of our number as we work our way through. Now, we go back to Pivnert, or ideal gas law. We're solving for volume, so we arrange it to solve for volume. So nRT over P, plug our numbers in. We have 4,240.514 moles. We're going to be working in kilopascals, so I have 8.314 is my kilopascals because our label up here is kilopascals. I have 373 kelvins because we had to convert this to kelvins. And we had 110 kilopascals of pressure. Plug all that in and solve, and we get this gigantic number in liters of carbon dioxide. Okay, so we're still in liters. The question did ask for gallons, so let's convert that over. Take this 119,538.5 liters of carbon dioxide, convert from liters back to gallons, and there is your gigantic correct answer. And yes, that is a realistic answer. Every time you burn a gallon of gasoline in your car, you're putting 31,000 gallons of carbon dioxide into our atmosphere. Okay? Keep in mind, the ideal gas law, we have 5 things in here. You always need to know 4 of the 5 to solve for the problem. The one piece that was missing, we didn't know moles. You knew the pressure, you knew R, you knew the temperature, we solved for volume, so the stoichiometry gives us moles to solve that. Alright guys, that's the end of the video. Any time you have left in class, please use working on worksheet number 2. Thank you.